Hello, I'm Dr. Charlie Collins. Let's talk about research methods. Today, I'm going to talk about the process of quantitative data analysis. I will discuss data processing, types of data analyses, and I will leave you with some concepts to consider. As we discussed on the topic of measurement and in other places, quantitative data are observations that have been transformed into numbers or counts. These numerical data can be collected in a multitude of ways, such as direct observation, like counting the number of red cars that pass by, or through self-report, such as a survey. Quantitative data analysis takes those numbers and conducts statistical analyses to understand trends and relationships in the data. But to get from observations to interpretation takes a process. So let's walk through this process. To get to data analysis, quantitative researchers must first process their data. Data processing has 4 components: coding, editing, entering, and cleaning. Let's say, for example, I'm interested in the studying habits of my students and how those habits may relate to their grade in my class. To study this, I create a survey that asks questions such as, quote-unquote, on an average school week, about how many hours do you study, and what is your overall GPA? Let's say I also want to collect demographic information as well, such as income, race, gender, and so on. Fairly basic questions, right? Well, the first step in processing is the coding phase. This is when the researcher takes the observed information that was collected and turns it into numerical data. For example, if I were to ask your number on race, you'd probably give me a weird look, right? That's because we need to take categories of race, which have no intrinsic numerical value, and give them numerical values, or assign them numerical values. This coding process allows us to turn our non-numerical information or observations into numerical data, so that our statistical software can analyze those data. Second, I need to edit the data, which is checking for errors and other issues that may occur in the data. For example, say on the survey I'm giving my students, someone wrote that they study 170 hours a week. Considering that there's only 168 hours in a week, I know this can't be accurate. So I have to make a decision about that data and change it or remove it. Perhaps the person meant 17 hours a week and accidentally wrote a 0. Who knows? Editing also checks for missing data, which is data that is absent, and creates and enters a code for the missing data. These are any skipped questions in my survey, for example. Third, I need to enter the data. This is the process by which we create codes for our variables, ID numbers for our respondents, and enter the numerical values for each response. These data should be entered in a data file like Excel or SPSS or Stata for computer analysis. And finally, the data cleaning process examines the data to correct for errors created earlier in the other 3 processes. Data cleaning looks for unusual or extremely outlying data. It checks for consistency in the codes and makes sure all entered data were entered into the correct variable. This provides analysts with a quote-unquote clean data set for which they can use for analysis purposes. After we have cleaned the data set, we can begin analyzing our data. Just an interesting side note, second to data collection, data processing is the most time-consuming component of quantitative research. There are 3 types of data analysis: univariate, bivariate, and multivariate. Univariate analysis is the analysis of a single variable using what we call descriptive statistics. Descriptive statistics looks at various characteristics of each variable, such as the average, or what we call the mean, the middle point, what we call the median, the most frequently occurring observation, what we call the mode, and the range of values, for example. Other types of descriptive statistics include things like percentages and frequencies of values. While univariate analyses are used to describe the data, they can also be used as a component of the data cleaning process, as it can help identifying issues with things like extreme outliers, for example. Bivariate analysis examines the relationship between 2 variables. There are a variety of specific statistical techniques used in bivariate analysis, such as t-tests, chi-squared, and correlation that I'll not get into right here. Just know that each one examines the relationship between 2 variables and their use depends on the level of measurement, meaning nominal, ordinal, interval, and ratio. Bivariate analysis also helps identify data errors that may occur. For example, let's say in my survey I identify a 17-year-old student, which would be a little strange but not completely out of the realm of possibility, and I also identify a case where the student has a yearly income of $1 million. Also a little strange, but not necessarily out of the realm of possibilities. But even stranger would be a 17-year-old student making $1 million a year. Bivariate analyses helps me identify this bivariate outlier. Finally, multivariate analyses, like bivariate analysis, helps understand the relationships or associations between variables. The difference is that multivariate analysis uses 3 or more variables, usually in the form of multiple independent variables predicting a single dependent variable. Like bivariate analysis, multivariate analysis has many statistical tools such as structural equation modeling, hierarchical linear modeling, and longitudinal analysis, for example. However, the most common is multiple regression analysis. Multiple regression examines a relationship between 2 or more independent variables with one dependent variable. Multiple regression is also considered a predictive analysis method. Not predictive because it can tell the future, but predictive because based on the sample data, the model can provide a score on the dependent variable given hypothetical scores on the independent variables. In other words, it can quote-unquote predict the score of a dependent variable based on the observed scores of independent variables. Multiple regression is the most widely used statistical method in the social sciences, and most other complex statistical analyses, such as hierarchical linear modeling, is based on the foundation of multiple regression and linear regression. Well, that's all we have for this discussion on multiple methods. By now you should be familiar with data processing, types of data analyses. But before we go, I want to leave you with some concepts to consider on this topic. There are many concepts in quantitative analysis methods. I'd recommend checking out my stats videos if you have more interest. In either case, some concepts you should know that we may or may not have covered are: a dummy variable is a variable that has 2 categories, usually something like a yes or no type variable that is coded 1 and 0. A frequency distribution, also a frequency table, is a tabulation of the number of cases that fall into each category of a certain variable. This is a univariate type of analysis. A histogram, which is a visual graphic that looks like a bar chart, is also used for univariate analysis with interval ratio variables, and is used to visually identify the frequencies or percentages of cases in each category. Missing data are data that are absent or missing from the dataset. Outliers are unusual or suspicious values in the dataset. The range is the distance between the lowest value and the highest value in a variable. That is all I have. Thank you for watching. I'm Dr. Charlie Collins, and I will see you next time.